In this video, we are going to discuss in relation and functions class 12 chapter example 3 and example 4. This is example 3. Let L be the set of all lines in a plane. L be the set of all lines in a plane and R be the relation in L. Defined as R, L1 comma L2. Set of all L1 comma L2. L1 is perpendicular to L2. Show that R is symmetric but neither reflexive nor transitive. Means, the question means L is equal to set of all lines in a plane. Okay, set of all lines in a plane like this. Okay, L1 and L2, L3, etc. Okay, set of all lines in a plane. R with the relation in L. Okay, they are written a relation in L. Okay, and the relation is like this. Set of all ordered pair L1 comma L2. L1 is perpendicular to L2. Set of all ordered pair L1 comma L2. L1 is perpendicular to L2. L1 is perpendicular to L2. You have to consider this as L3. L1 is perpendicular to L2. And one more set of all lines means I written only 3 lines. One is L1 is perpendicular to L2 and one more is L3. And this relation is what? Set of all L1 comma L2. L1 is perpendicular to L2. The condition is L1 is perpendicular to L2. We have to show this relation is symmetric but neither reflexive nor transitive. We have to prove this relation is symmetric, is not a reflexive and is not a transitive. We have to prove. Okay. First we will prove reflexive, next we will prove symmetric, next we will prove transitive. Okay, first is symmetric. Symmetric is nothing, first we will prove reflexive. Okay, first we will prove reflexive. Reflexive is nothing but in the ordered pair, first element and the second element it should be the same. First element and the second element it should be the same. Here first element is what? L1. L1 is perpendicular, the line itself we have to write like this, L1 comma L1. The line itself is a perpendicular. It is possible L1 is perpendicular to L1. No, it's not possible. So the line, it's our condition is what? Our condition is L1 is L1 is the line. The two lines are perpendicular to each other. But reflexive means same element. First element and the second element it should be the same. L1 is not perpendicular to itself. L1 is not perpendicular to itself implies that, or that is L1 comma L1 is not belonging to R. Okay, same elements we need in the ordered pair, first element and the second element it should be the same, but it is not possible. The line itself is not a perpendicular, so this relation is not a reflexive. Next we will check the symmetric. Symmetric means what? A comma B belongs to R. This implies B comma A belongs to R. Means A comma B belongs to R implies what? B comma. We need reverse ordered pair. Here it's here same ordered pair, but here reverse ordered pair we need. A comma B belongs to R, then B comma A belongs to R. Reverse ordered pair we need. We shall check now. Okay, here what? The L1 is perpendicular to L2. L1 is perpendicular to L1 is perpendicular to what? L2. L1 is perpendicular to L2. That is we can write it as L1 comma L2 belongs to the relation R. Next is belongs to the relation R. Can I say L1 is perpendicular to L2? We can say reverse L2 is perpendicular to L1. We can also say L2 is perpendicular to L1. Okay, that is we can also write we can also write L2 comma L1. It's exist, no? It's exist. See, A comma B belongs to R. A comma B implies what? B comma A. Here L1 comma L2 implies L2 comma L1. We can say reverse also. L1 is perpendicular to L2 or L2 is perpendicular to L1. So this relation is what? This relation is symmetric. Hence symmetric. Okay, this relation is what? Symmetric. Next is last relation is what? Transitive. We have to check the transitive. Okay, we shall check now. Our transitive condition is this is the transitive condition. See, this is transitive condition. What? A comma B, this is considered A comma B belongs to R and B comma A belongs to R. This implies B comma C belongs to R. This implies A comma C belongs to R. A comma C belongs to R. See, the condition of the transitive is A comma B belongs to R, B comma C belongs to R implies what? AC belongs to R. We have to consider here L1 comma L2. L1 is this ordered pair L1 L2 belongs to R. This means this means L1 is perpendicular to L2 and A comma B. Next is what? B comma C. A comma B means L1 comma L2. B comma C means L2 comma L3. L2 comma L3. Okay. This implies what? A comma B. B comma C implies what? AC. This implies that what? This implies what? L1 comma L3 is possible. L1 comma L3 is possible. L1 comma L3. Here L1 comma L2 means perpendicular. L1 is perpendicular to L2. L1 comma L3 means L1 is perpendicular to L3. L1 is perpendicular to L3. L1, this is the L1 line and this is the L3 line. These two are perpendicular. These two is not a perpendicular. These two are what type of lines? Parallel lines. So this implies this L1, we are getting parallel lines. We are not getting the perpendicular lines. So L1 can set up ordered pair L1 comma L3 does not belongs to the relation R. Hence it is not a transitive. Hence it's not a transitive. Okay, hence it is not a transitive. Therefore the relation is what? Relation is symmetric, but neither reflexive nor transitive. Neither reflexive nor transitive. Now transitive. Okay, this is about example 3. Next we are moving to the example 4. So when once again I am explaining again. Reflexive means we need the same first element and the second element, it should be the same, but the condition is L1 is perpendicular to L2. Here first element and the second element, it should be both are perpendicular to each other, but L1 is perpendicular to L1 is not possible. The line itself is not a perpendicular. Okay, next is here A comma B implies B comma A. L1 comma L2 implies what? L2 comma L1. L1 is perpendicular to L2, L2 is perpendicular to L1. Okay, therefore hence it is the symmetric. And next is transitive. Transitive is nothing but A comma B belongs to R, B comma C belongs to R implies A comma C belongs to R. It is also not possible because L1, L3 is not perpendicular. These two are the parallel lines. We need perpendicular lines. So this relation is not the transitive, and therefore the relation is symmetric but neither reflexive nor transitive. Okay, next we are moving to the example 4. Example 4 is, show that the relation R in the set 1, 2, 3 given by R is equal to 1, set of all 1, 1, 2, 2, 3, 3, 1, 2, 2, 3 is reflexive but neither symmetric nor transitive. Okay, here the set is 1, 2, 3. The set is what here? 1, 2, 3, and the set is 1, 2, 3, and this is the relation. What is the relation? Relation is set of all ordered pair 1, 1, 2, 2, 3, 3, 4, 4, 1, 2, again 2, 3. Okay, we have to prove this relation is reflexive, but not a transitive, not a symmetric. Our question is, this is the set. For this set, they are written the relation. Okay, we have to prove this relation is the reflexive but not a symmetric but not a transitive. Okay, so we will check first reflexive. Okay, we will show that it is not a it is not a reflexive. Okay, first proof is, first we will show it's not a reflexive. It's a reflexive. First we will prove it's a reflexive. Okay, what is reflexive? First element and the second element. First we will show that this relation is the reflexive relation. Okay, we reflexive means first element and the second element, it should be the same. First element and second element, it should be the same. And okay, we will check. First, in the ordered pair, first element, second element same. Here also 2, 2. Here also 3, 3. Okay, stop here. We having the set elements 1, 2, 3. Till 3 we have to check. First in the ordered pair, first element and the second element same. Okay, then 1, 2, 2, 3 is there also, no problem. So therefore this relation is what? Reflexive, because 1, 1, 2, 2, 3, 3 lie in R, hence it is reflexive. Next we will check the symmetric. Okay, next is check symmetric. Okay, so symmetric is what? A comma B belongings to R implies what? B comma A belongings to R. This A comma B implies B comma A, reverse. A comma B, B comma A, reverse. Symmetric is nothing but reverse ordered pair. That is, we call it as the symmetric relation. Okay, here we will see 1, 1 is ulta reverse 1, 1. 2, 2 reverse is 2, 2 is there. 3, 3 is 3, 3 only reverse. Okay, 1, 2 reverse is what? 1, 2 reverse is 2. 1, 2 reverse is 2, 1. It should be there. 1, 2 reverse 2, 1. It should not. It's not lie in R. 1, 2. 2, 1 is not lie in R. Okay. Therefore, this is not a what? This relation is not a symmetric. 1, 2 belongs to R, but reverse of this 1, 2 belongs to R, but 2, 1 is not belongings to R, and hence it is not a symmetric. It is not a symmetric. Next we are checking transitive. Okay, check the transitive. Okay, transitive means what is the condition? Transitive condition: A comma B belongs to R, and B comma A comma B, B ends B comma C. Okay, A comma B, next is B comma C. Alter A comma B, next starting is B comma C. We need what? Implies A comma C. This condition we need. Yeah, A comma B, B comma C implies what? A comma C we need. Its belongings to the relation. Then this is then this condition is called it as the transitive. Okay, we will check 1 comma 1. Here 1 comma 1. This is A and this is B. B is what? 1. Again B is 1. Again we have to check 1. 1 comma 2. This is what? This is B comma C. This is A comma B and this is B comma C. A comma B, B comma C. We need what? A comma C. A comma C is nothing but 1 comma 2. Yes, 1 comma 2 is present here only. Next, this is over. Second, you have to take the second ordered pair. 2 comma 2. This is A and this is B. Okay, 2 comma 2. B ends with 2. Again, B ends with 2. 2, you have to search 2. Okay, here, starting here 2. This is B comma C. Okay, A comma B, B comma C. We need A comma C. A comma C is nothing but 2 comma 3. 2 comma 3. 2 comma 3 is also present here only. Then it is symmetric. Next check 3 comma 3. 3 comma 3. 3. This is A and this is B. BC means 3 comma something. 3 comma one more element. But 3 comma is not 3 like that. What ordered pair is not present. Then leave it. Next check. 1 comma 2. 1 comma, this is A and this is B. Again B comma C. B comma C is nothing but 2 comma one more element. This is B comma C. Means we need again what? A comma C. A comma C means 1 comma 3. 1 comma 3 is present. In this 1 comma 3 is not present. Here 1 comma 3 is not belonging to the relation. Is not belonging to the relation. So this is not what? Hence it is not transitive. It is not transitive. So we are showing this is the reflexive but not symmetric but not transitive. Therefore the given relation is reflexive, neither symmetric, non-transitive. This is the explanation of example 4. Okay, so once again, this is reflexive means ordered pair are in the ordered pair, first element, second element it should be the same till 3. First element and second element it should be the same till 3. Then we are getting the more ordered pair also, no problem. Then this is also reflexive. Next is symmetric means 1 comma here 1 comma 2 is there but 2 comma is not present. That's why it's not belonging to R. That's why this is not the symmetric. We need the reverse ordered pair. Why it is not transitive? Here 1 comma 3 is not belonging to R. That's why this is not a transitive. Okay. Next, therefore the given relation is reflexive, neither symmetric nor a transitive.